Hello guys, welcome to our channel 10 Minutes Code, and today we are going to start with NumPy. So this is the NumPy is the part of this machine learning course, and we are going to learn this in this video. So first of all, what is NumPy? NumPy is nothing but we work on arrays in Python. So in Python we have list, but it is very slow to process, so that's why we have created the NumPy module, or we can say package that have array as data type. Okay, so we are going to create a NumPy as .ipynb. We are going to use Jupyter notebook. Okay, fine. So what I'm to tell that first I'm going to write, there are two options in Jupyter notebook for code, for markdown. Suppose so NumPy arrays, or we can say in NumPy arrays we also call them ND array. Okay, NumPy array can also be called as ND array, and is 50 times faster than Python list. Okay, that's why we are using NumPy arrays, and it is used in machine learning and data science because they are faster, and they are machine learning and data science. So they are used in machine learning data science because they are faster and they are best as compared to Python list. Okay, so they are also called as ND array. So let's start with the code and the topics we are going to cover. In this topic we are going to cover all the basics of NumPy. So we are required in machine learning for further. So first step, we are going to install pip install NumPy. So it will install the NumPy at a computer. To run the NumPy you should have already have Python installed. So first we are going to import NumPy as NP. So we are going to import NumPy as NP, and we are going to use NP instead of NumPy in this. So to check out version of your NumPy, you can write np.version, and to run the particular block of code in Jupyter notebook you can press Ctrl plus enter. Okay, so this is the version of my NumPy, and now we are going to create one more code, and we are now going to create an array. Okay, so let me show you creating array. So how we can, when we create an array, we are creating one variable and we are assigning np dot array. This is a built-in function to create array in NumPy, and let's give this as array1, and now we are going to assign a value 1, 2, 3, 4, 5. So this is a one-dimensional array, and if I print this, then you can see this is an array. Okay, now you can see this data type is array. So this is how we create an array in NumPy, and you can also create a two-dimensional array here. Suppose array2, and we can copy this, or we can just divide this in two-dimensional array. So this is a two-dimensional array. Let's print the 2. So wait a second, 4, 5 np dot array 4, 5. Just a minute. So it will be like this. np dot array. Wait a minute. So np dot array, it will be like this: 1, 2, 3, and 4, 5, 6, and it will be inside this two one-dimensional array. Would be inside of one-dimensional array. So this is a two-dimensional array. Fine. So that's how we are going to create. Okay, now we can also print the dimension of array. So let me write the markdown array dimension. So this shows how many dimensions the array is. For example, this is one dimension and this is two dimension. Let's print this. So array1 dot ndim. So this is ndim. We are going to use n dimension of this. So this is the one dimension array, and when I print the n dimension of array2, so it is two dimension array. Okay, so suppose I am creating an array of 0 dimension. So how when we create nb dot array, and we are not going to provide this bracket here, we are going to directly enter the value. So suppose now if I print array of 0 dot n dimension, so it's a 0 dimension array. Okay, and if I want to create a 3-dimension array. So it's just the same process. 2-dimension array is just a collection of multiple 3-dimension array is just a collection of multiple 2-dimension array, and 2-dimension array is a collection of multiple 1-dimension array. That's all. So here we are taking 2-dimension array here and comma here. Yeah, let's print the array 3.n dimension. So it's a okay 3.n dimension 8 1 2. Let's okay, first of all let me copy this. This is 2-dimension array. Okay, fine. And this is also there are two 2-dimension array, and we are going to combine these in a 3-dimension array. Let me print first array 3. So array 3 is what's happening like this. Let me just comment out this. Sorry, instead I have by mistake written here. So this is a 3-dimension array, and if I print n dimension, then it's a 3-dimension. Okay, that's all. So to create an array, we use np.array. To find the dimension, we write .ndim, and this is to create array. Okay, that's all. Now the next step is array indexing. Okay, so array indexing. Fine. Now here let me just take these arrays here. So this is 1-dimension array, this is 2-dimension array, and this is 3-dimension array. That's fine. Let me assign 4 5 6. Let me change the values here so that we can 9 and 10 11 and 12. The fine. Now let's try to check out the dimension. So first we are going to index this first 1-dimension array, so we can directly index. So for example, array 1 of 7 is not defined because it's only of 5 size, so we are going to write 4. So we can see at this 4th index we have 5 element. Okay, 0 1 2 3 4. As we know, the array indexing starts from 0, and this is for 1 dimension. And if we want to access the 2-dimension array, so we can do like this. So first we have to take this, so this will be the 0. Okay, so 0th element. So this is a 2-dimension array. So in 2-dimension array, this is multiple 1-dimension array. So this 0 will print the first 1-dimension array, and inside, if you want to print the element inside of it, so we can write 1. So we got the 0th means this value, and the first index of this value is 2. Okay, or we can also write like this. For example, array 2 and 0 comma 1, it will print the same. Okay, we can write either this, we can write either this. So let's print for array 3. So first of all, we're going to skip this bracket, and we're going to see, so there is 2-dimension array. So I am going to take this one, so array 3 of 1 comma, and then I am going to take this one, so this will be 1, and I'm going to take this 12, so this will be 2. So I got the 12. Yeah, this is how we can indexing the array. Suppose it can also have minus value. Suppose I write -2, then we got 1. So because it is -1 and this is -2, we can also do a negative indexing in array. Okay, now let's check out what is array slicing. Array slicing is nothing but we can find the subparts of array. Suppose this is array. Okay, suppose this is array, and now we have to slice this array. Okay, so we can do array 1 comma 4. So this is a starting point, this is the ending point. Let's check it out. Sorry, yes, very good. Yeah, fine. So from 1, so 0 index, 1 index, 1 2 3 and 4. Okay, so it will run, it will print value from first index to third index. Okay, this will not include the fourth index. Okay, it will be the -1. Okay, so 1, 2 and 3 index will be printed. So what if I skip this part at the start part and I directly write a 4? So it will print from 0 starting position if we skip this part, and it will print the fourth index. Okay, I mean, yeah. So if I skip the second part, for example I write here 2 and I skip this, so it will print from second index, which is 3, and print all after that. Okay, till the end. And if I skip both the path, then you know what will happen. Yeah, it will print whole array. Okay, this is called array slicing. And we can slice in negative also, negative portion also. Suppose I have -2, so it will skip these 2 parts. Okay, so it will print only till 3. Yeah, this is how we can also do negative slicing. So there are also data types of array. For example, this is an array. Okay, and if I write array 1 of d type, then we can see that it is of int 32 type. So if I write here 0.0 and if I write it, then it's a float 64, or we can assign the data type to. So d type, suppose I want to give this i4, then it will be int 32, and I will give this i8, and it will be int 64. That's how we can assign the data type also. So the next thing is copy versus view. So this is very interesting topic in this copy versus view. So just listen carefully. What copy does: if we create a copy of an array and we manipulate or change the value of the original array, then it will not reflect the copied array. Okay, but in view, when we create a viewed array of existing original array, and if we change the view of original array, then it will also reflect the changes in the copied array. Let me show you with the example. Suppose I am taking this array as an example. So suppose I'm taking this array as an example, and I will create a variable x where I am going to array1 dot copy. Okay, so let's print array1 and print x. So both are same because, wait a minute, so here it will function. So both are same because we have copied. So suppose if I change here the value of array1, so array1 of 0 I write here is 45. So we can see the array1 value has been changed, but x is already the same, 1 2 3 4 5. Suppose if I write here, so let me take another block cell, and instead of this copy I am going to write a view. So when we see that, when we change the original array in view, then the viewed array will also be changed. This is the difference between copy versus view. This is the important topic in NumPy. So the next topic is shape. Okay, array shape. So it just provides you the shape of an array. So array1 dot shape, let me show you. Sorry, we don't choose. Okay, so it's of 5 elements. So 1 0 1 2 3 4 5. Okay, 1 2 3 4 5, just 5 elements. Suppose if I write here array2, which is the 2-dimension array, so it gives you, there are 2 1-dimension array. Inside both the 2 1-dimension array there are 3 elements. Okay, so if I write a 3-dimension array, so it will show you there are 2 2-dimension array, and each 2-dimension array there is 2 1-dimension array, and each 1-dimension array there is 3 elements. That's how its shape is gonna work. Okay, now the next thing is flattening, array flattening. So what is it? Before array flattening, let me show you what is array reshape. Okay, so array reshape, that's all. And now suppose this is array. Okay, we are going to increase the value. Suppose I am going to write 6 7 8, and I will do array1 dot reshape. So I am going to write a 2 2 2. Okay, and we are going to print array1. So wait a second, sorry, I am going to print only the array reshape. So what it has done is it has reshaped all the values by 2. Okay, so this is creating 3-dimension array because we have provided 3 values in the reshape function, and it cannot reshape by anything. Suppose I write here 1, so it will create an error. I will tell you why. Because 2 2s are 4, 4 2s are 8, and there are 8 elements in this, so we can we have to multiply and we have to put. Okay, so if the multiplication is wrong, so 2 2s are 4, 4 1s are 4, and there are no 4 elements, there are 8 elements, so it will not perfectly reshape. Okay, it will create an error, so it should be same like this. Okay, or we can create 4 comma 2, which is 4 2s are 8 and there are 8 elements, so there are, it can reshape. Or we can see 2 comma 4, so because there are 5 elements. Okay, suppose there are 6. Okay, 6 elements, and I write here 2 comma 2. Okay, 3 comma 2, which is 3 2s are 6, so it can reshape. Okay, that's how the reshaping of the array works. So if I putting if we have put 2 values, then it will reshape to 2-dimensional array. If we have put 1 value, then it's going to reshape into 1-dimensional array. And if we put 3 values, okay, then it will reshape to 3-dimensional array. That's how it's gonna work. Okay, fine. Now, what is array flattening? It's simple. It will, suppose there is a 3-dimensional or 2-dimensional array, it will just convert that into a 1-dimensional array. Let me show you. I'm just copying this 3-dimensional array and I'm going to paste this here. And what I'm going to do is, we are going to array 3 dot reshape, and here we are going to write -1, and it will reshape it into 1-dimensional array. So suppose let's do, we are writing here -1, suppose, so it will, so this -1 will automatically predict the value which will come here. Okay, by doing some multiplication. Yeah, so this will predicted by compiler, or if you write here, it will predicted by you. Okay, now the next thing is array iteration. So suppose this is an array. Let me first take a 1-dimensional array. I'm going to write the code, and so what we can do is, for array in array1, and we can print the array. Okay, so it is iterating the 1-dimensional array. Suppose this is a 2-dimensional array. Okay, suppose this is a 2-dimensional array. Let me take a 2-dimensional array. Fine. Now let me take a 2-dimensional array and let's do this. So it's printing like this. Okay, if we print a single value, so we can write for x in array, and we can just do this like this. Sorry, array 2. Array 1 array. Okay, what's the problem? Okay, we have to print x. Okay, so this is how it's going to print all elements in the array. Suppose I'm writing a 7, so it should be same, everything will be same, so it will print the whole dimension of the array. Okay, so just like it will, if we write here for y in x, it will print the 3-dimensional array. Let me take 3-dimension. Sorry, I'm going to prepare y, so it will print 3-dimensional just like this. So there is an inbuilt function which is and iter. Okay, iterating, we can also iterate to that. So we're going to write for x in and p dot and iter, and we are going to pass here array, and we are going to print here x. So it will also print the by single. We don't have to write the 3 loops or 2 loops. It can be printed with the help of and p dot and iter, which is an inbuilt function in NumPy. So the next one is array concatenation. Okay, so suppose there are 2 array 1 2 3 4 5 6, and array 1 1 is equal to np dot array, which will value 7 comma 8, and now we are going to concatenate. So we are going to write np dot concatenate, and we are going to pass 2 array inside this, array 1 and array 2. Let me show this. So all dimensions. Okay, wait a minute, let me just print this. Sorry, So we can see that this is concatenated this 2 array. Just like this we can concatenate also 2-dimension and 3-dimension array. So next step is array splitting. Okay, so suppose this is an array. Okay, let's take it as 8 and 9. Okay, and 7 too. Fine. So if I print here np dot array and split, then we are going to pass array 1 and we are going to write the parts we split. So it's split into 3 parts. Okay, this we got 3 array. It what is going to will return the list of 4 array. Okay, list of 4 array will be 3 array will be written. And if I write here, if I write here, wait a second, if I write here 8 and if I write it 2, so 8, and if I write here 2, so it will split into 2 array. It can also split into 4 array. It can also split into 8 arrays. Okay, suppose if I write a number, so it can split into 8 arrays. Here 1 2 is written and 3 4 5 6 7. So it's an inbuilt array splitting function inside a NumPy. The next is array searching. Okay, let me show you array searching. Fine. So there is an array 1. This is an array 1. So array searching, there is an inbuilt function where. Okay, let me show you. So we can do is np dot where, or we can search array 1 is equal to 6. So it will print the, okay, just a minute. np dot where, so it will print the index where the 6 is there. So index is 5. Okay, or we can say we can print the np where array 1 modulo 2. So it will print only the modulo 2 values. It's not equal to 0, so sorry, or we can modulo 1. Okay, so here if it's array 1 modulo 2, then it will print all the values which will be modulo 2. Okay, which is the remainder of 2. So next is search sorted function. Okay, so what search sorted function do, let me show you. Sorted. Okay, fine. Now suppose this is an array. Let me remove the word 7 from here, and I am going to write np dot search sorted array 1, and I am going to pass here 7. So what it will do is it will return the index where the 7 should be put. Okay, here 0 1 2 3 4 5 6 7, so 7 will be here. Okay, this will work on sorted array and it will show where the 7 should be put inside this array. Okay, to be sorted. Okay, and the next is sorting. So how can we sort the array? Suppose this is an array. Let's shuffle the values here. 6 0 3 4 3. So it's going to sort the array. So we will write np dot sort, and we are going to pass the array 1, so it will sort the array. Okay, this is an inbuilt function. So that's all for today. That's all for these are the basics of the NumPy that we should know before proceeding to machine learning. Okay, so there can be more operations in arrays like random permutation, normal binomial and Poisson distribution, and much more things can be performed on this array with the help of Seaborn and Pandas library, and which will be discussed in our upcoming videos in machine learning course. So that's all for today. So in this machine learning course, in the first lecture we have completed Pandas, and now we have completed NumPy. In the next lecture we are going to proceed further with the next Python library or the next machine learning algorithm and many projects. So if you are interested in machine learning, web development and lead code, then you can subscribe us at 10 minutes code. Thank you.